Good morning, folks. Welcome to 4.3, where we talk about correlation. All right, so yeah, let's get into it. So correlation is designated by the letter R. I don't know why it's R, but they use R. R is our correlation letter for correlation coefficient. It is a number in the range of -1 to +1. So it's always in that range, -1 to +1. And it's a metric. It measures the strength and direction of a linear relationship between two quantitative variables. So think of like the dunk contest, the NBA dunk contest, where someone dunks it and then they give them a score like, oh, that was a 10 out of 10. That was a perfect dunk. Or like it's like a 3 out of 10. That was like a pretty crappy dunk. That's what the R value does for scatter plots. Basically, it sort of gives a value to how strong the correlation is or how weak the correlation is, as well as if it's positive or negative too. So if R is close to 1 or -1, it is considered a good fit. Basically, like that's getting a high score in a dunk contest. So 1 or -1. So remember, +1 or -1 are both good fits. Anything close to those numbers. If R is close to 0, the model is not a good fit. So it could be like -0.2, +0.2, something close to 0 is not a good fit, whether it's positive or negative. If R equals +1 or -1, if R is exactly 1 or exactly -1, the model is a perfect fit. Keep in mind, this is true for -1 and +1, right? -1 is a perfect negative fit, and +1 is a perfect positive fit. If R equals 0 exactly, there is no linear relationship. If the relationship is negative, the R value will be less than 0. So that's like a decreasing relationship. If the relationship is positive, R will be greater than 0. So that's like an increasing one, right? One that goes upwards versus, of course, a -1 that goes downwards. All right, so a correlation greater than 0.8 is generally considered as strong, whereas a correlation less than 0.5 is generally described as weak. Anything kind of between that is usually more like moderate. So here's some kind of visual aids to help you. So a perfect positive correlation, this would have an R value of exactly 1 because it's perfect in a line positive correlation. The one next to it, a strong positive correlation, this would probably be something like a 0.8, 0.8, 0.9, something like that, where, it's not perfect, but it's still pretty high. A weak positive correlation, so something a little more spread out. This one would probably be, I don't really think this visual is that weak. I would more call this a little more moderate, but we'll say weak, just as an illustration. So we'll say it's roughly maybe 0.5. And then no correlation. You can see there's no pattern at all, so that's going to be R equal to 0. Now on this side, it's pretty similar to the other side, but they're negatives. So a weak negative correlation, this would be R equal to -0.5, roughly, just an estimate there. This one is pretty strong, but again, negative. So this would be like R equals -0.8, something like that, -0.8, -0.9. And this one is a perfect negative correlation. So this one would be R equals -1. So closer to 0 you are, the weaker it is, but the closer you are to 1 or -1, the stronger it is. Just depends, again, whether it's positive or negative, right? Is it increasing or decreasing? That's the only difference there. A couple really important facts to remember. A correlation close to 1 or -1 doesn't imply association is linear. So an example here is look at this scatter plot on the right. The scatter plot on the right is clearly not linear. You can tell it's definitely got this like curve to it. And so it's definitely not linear. However, its correlation coefficient is still 0.93. So the scatter plot to the right is clearly non-linear. But its correlation coefficient is still 0.93. That's still a very high correlation. So you would think, oh, it's a very strong correlation, but it's not linear. right? It's not linear. So just because it's a high correlation doesn't necessarily mean that linear is the best fit for it. And another important point is correlation does not imply causation. Just because there's something's related to one another doesn't mean it causes the other thing. So yes, the weight of gold, I'm guessing, does impact the price, but the weight of gold doesn't cause the price. If that makes sense. You know, some person decides like what it costs, right? The weight has an influence in the price, surely, but the weight doesn't cause the price. So, you know, keep that kind of stuff in mind. All right, and just a couple estimates just to kind of get us a feel for what things are. So here you can see we have a negative correlation, and it's not very strong. You know, this one, you can tell there's a pattern there. It's probably a pretty moderate correlation. So I would say maybe R. This is just an estimate, right? Something close to maybe like negative 0.7, 0.6, something like that. We don't know exactly, right? Unless we use a calculator and type in all these data points. The one on the right, though, is a little stronger. It's positive, but you can tell it's a little stronger as well because the pointers aren't as spread out. So this one would probably be like 0.8, positive 0.8, right? Because it's positive and, you know, they're a little closer together. All right, now we'll interpret the correlation coefficient. So if R is 0.98, if we, you know, use data points, put it in a calculator, we get R equals 0.98. We would say this is a very strong positive relationship, positive correlation. If we got an R value that was negative 0.21, we would say this is a very weak negative correlation, weak negative relationship. And finally, if R was positive 0.65, you know, that's not that weak, but it's definitely not that strong. This is more of a moderate positive relationship. So yeah, just kind of a rundown of what the R value is, what correlation is. Remember, correlation, sum it all up, is basically just a way to measure a scatter plot's strength. The two variables compared to each other to measure how strongly correlated, how strongly associated they are. So it's a way of measuring that is what it is. All right, that's gonna do it. I'm gonna wrap it up here. I'll see you guys in the next one. Adios. Bye for now.